To example 7 from our notes from section 3.2 about polynomial functions. And in this example, we're trying to find possible equations for the graph that we had in example 6, this graph right here. And in example 6, we determined that the function has to have odd degree, positive leading coefficient, with zeros at -3 here, with even multiplicity because the graph bounces off the x-axis there, and a 0 at x equals 5 with odd multiplicity. So I've summarized that right here at the top so we have it. And I also put it here. So we're looking for functions that are odd degree with positive leading coefficient with zeros at -3 with even multiplicity and 5 with odd multiplicity. So we're just going to go through one by one and see if each of these functions satisfies our requirements. So the first one, letter A, if we look at the degree here, this is a polynomial function in factored form. So in factored form, the degree would be the highest exponent that we would have if we were to multiply out this polynomial. If we were to do that, this would become a quadratic. We'd have an x squared term, so this would have even degree. On that basis alone, we can eliminate letter A. Letter B, if we look at the degree here, it's in factored form. The degree is 2 plus 1, which is 3, so it's an odd degree. So that's good, but the leading coefficient is -3. So it has a negative leading coefficient that doesn't match, so we can eliminate example B. Letter C, let's take a look at the degree first. So if we were to multiply this out, our highest order term would be an x to the 4 plus 1 or x to the 5th. So this is odd degree, so that matches our requirement. The leading coefficient is 10, which is positive, so that matches our requirement. What about the zeros? We have a 0 at -3 with a multiplicity of 4, so that's even, so that matches. And we have a 0 at +5 with a multiplicity of 1 because we have an exponent here of 1. So letter C could possibly be the graph of the function that we see in example 6. Let's take a look at letter D. Letter D, if we look at the degree, it's going to be 2 plus 1, which is 3. So odd degree, that's good. Leading coefficient, nothing's written here. That means it's a 1, and that's a positive leading coefficient. The zeros that we have are at 3, not -3. So because of this factor right here, we can eliminate letter D because this graph would have zeros at 3 and -5 instead of -3 and 5. Letter E. Here we'll look at the degree. The degree is 2 plus 1, which is 3 plus 1, which is 4. So this has even degree, so we can eliminate it on that basis alone. Another thing you might notice is we have a third factor here at x plus 1. This factor will give a 0 at x equals -1, which means our graph should have an x-intercept at x equals -1, which we don't have. So we can eliminate letter E for multiple reasons. Let's look at our last function. F of x equals 2 times x plus 3 to the 6th times x minus 5 to the 7th. The degree is going to be 6 plus 7, which is 13, which is odd. So the degree matches. The leading coefficient is 2, which is positive. So that matches our criteria. We'd have a 0 at -3 with a multiplicity of 6, which is even. That's what we want. We want -3 even. And we have a 0 at 5 with a multiplicity of 7, which is odd. So this could potentially be the graph.